trinomial is worthless unless you do what?
Factor it.
Factor it. So factor those two. And let's see what happens when you factor those two. Is that when you're bored? No answer? Okay, I wouldn't answer it either. The reverse FOIL method. Pronounce it however you like. I think we did this. No. Z. 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 And Z. All right? I did that much for you. Now, you may think this one's pretty simple because of the 6, because, oh, well, that's 2 times 3. Not all the time it's 2 times 3. That middle number right here tells you which one to use because of the signs. Let's say 2 times 3, because that's what everybody says. What kind of a 5 do I want? A negative. So that means that the biggest number has to be what? All right. What does this mean? Like or unlike? So that one works. But 2 and 3 ain't going to work down here. One of them, it doesn't work. I don't know which one might be. Yeah, there's another one that's 5 right here, or 1, I can't remember, and it doesn't work with 2 and 3. I think it's 4, 5. Yeah, 5. You have to use 1 and 1 times 6. You have to use 1 times 6. So you got to be careful on those. All right, this one's 2 and 3. And this tells us that our sign the positive has to go with what? The largest, which is 3. And this means what? Unlike. So that's a negative. And what happens to our z minus 2's? And you get z minus 3 over z plus 3. And where did I tell you were going to see this again? What did I tell you last week you were going to see this again? First week of calculus. When you do limits. When you start doing limits, you're going to have limit as z approaches infinity or 0 or whatever the case may be. And you can't put it in here because it makes a 0 pop in here, or if this one's not going to be like that. But they'll put a number here, and that number, let's see, 3 squared plus, I can't think of the number right now, but that number, if you plug it in here, it'll cause you to get 0 in the denominator. And that don't work. So what you do is you say, okay, you can't do the problem, or you got to do something else. Well, any math teacher will tell you that calculus problems are not that easy. You're not going to have a problem. You ever seen that? You ever seen this problem on, this comic? Where got 3 here and a 4 here and x, and the directions say find x, and the student goes, here it is. You ever seen that? Is anything that simple in math? No. Nothing is that simple in math. If you think that something is this simple in math, then you're missing the whole boat. Okay. Oh, she did. I didn't do that. Okay. So what I'm trying to tell you is when you get in first calc, you're going to get to this problem, or this problem right here, and they're going to have limit as z is 36 or something. And 36 will cause 0 to go in the denominator, and this here you're going to say to yourself, oh, okay, well that's it, you can't do it. No. That's an indicator that you're going to have to do what? You're going to have to factor and get rid of something, and then you can plug 36 into this one and get what on the bottom? 9 or whatever the case may be. You don't get 0, and that's the way they're fixed. All right, that's the way they're formulated. So, just an indicator. This is one of the things you're going to see. Several things that you're going to see in calc. Just just to give you a rundown. 1, you're going to see exponential laws, exponent laws, and you're going to see log rules. You're going to see those, which you learn in this class. All right, and you go over in this class. Logs are going to be about one of the last things we go over. Second thing you're going to have to be able to do, you're going to have to learn how to rationalize the denominator. You're going to have to know that. That's an assumption in first variable calculus that first week that you know it. Third thing is shortcuts and factoring. Factoring means reverse FOIL and the shortcuts. Fourth is complete and squared. Some of you have never heard of it. You will by the time I get through with you. And let's see, domain and range, which and reverse. In fact, those 4 or 5 things right there. If you don't know how to do those things without thinking, you're going to have a hard time keeping up in that first week, because you're going to be thinking outside of the box. Well, if the limit is x goes to 0, what does it do to this? So you got to be thinking about the limit. This, you don't need to be wasting time on relearning this. But that's what happens is students go in there and they're so hung up on the trig that they just covered that they get in there and they forget all the algebra that they've learned. So if you're going to Calc 1, I would keep this notebook handy. Really. Because you're going to need it that week before going over some of these problems. I would, if I was you. Just something to think about. Okay. I'll shut up. Next problem. Oh, well, let's check this one, make sure we're right. 3. Check. And check. And there's the answer. Z minus 3 over Z plus 3. So you feel good about yourself. Okay, this is called a fraction. What do you do when you get a fraction? You go into hammy mode and throw your pencil down and quit, right?
Can you blow that up?
No. That's what you do. You quit. Why? Because it's a fraction, and you don't need to learn fractions, do you? You just learn to avoid them. Yeah, common denominator, exactly. So let's get a common denominator. The common denominator here. Go ahead and write it down because I can't draw while y'all are about to load up. Load up, whatever you want to call it. 1 over 5a plus 3 over 4a plus 2 over a. Yeah, this will probably be our last review class, if we don't get into chapter 1 before. So, what is the common denominator of 4a, 5a, and a?
28.
20a. So you put a 20. Let me just rewrite. 20a plus 20a plus 20a. And how many times will 5a go into 20a? 4 times 1 is 4. How many times will 4a go into 20a? 5 times 3 is 15. How many times will a go into 20a? 20 times. 20 times 2 is 40. Dang old 40 plus 15 is 55. Dang old 59 over 28. That's the test question. Unit 1. Well, the actual way that you get a common denominator, I'll tell you. The actual way, because you're going to have somebody who blurts out, I just multiply 4 5 times 4. No, you're stupid, be quiet. Okay? That's not the way you do it. The way that you get the common denominator is you take 5, 4, and 5, and you do prime factorization, 2, 3, 5, 7, 11, and sometimes 13. And you break it up. 2 will go in there 4 times, 2 times, 2 will not go in there, so that's 5. 5 will go in there, 1 will go in there, I'm sorry, 2, I don't know, hold on. 2 will go in there 1 time, 2 will not go in there, and then you go 5 down, and 1 and 1. You get 1s all the way across, you have your common denominator. 5 times 4 is what? 20. Now, it just so happens that this comes out to be 20 because you multiply 5 times 4. Does that happen all the time with common denominators? No, it does not. You have to remember about 4 different rules when it comes to denominators. Or you can just remember one rule, and that is this right here. You should have learned this back in basic math, pre-algebra, somewhere in there. Right? Now, that's how you find the common denominator with a number. How do you find a common denominator with a exponent? Easy. You just use the highest or lowest exponent. Highest, Hubert. Yes, that's right. When you want to find a common denominator with an exponent, you always use the highest exponent. So, what's your common denominator of 5 and 4 and 1? 20. What's your common denominator of 8 to the first, 8 to the first, and 8 to the first? 8 to the first, Hubert. Yes. So the common denominator of 5a, 4a, and a is what? 20a. Now this was a squared, and this was a to the third. What would the common denominator be?
A to the third.
20a to the third. Now when do you use the smallest exponent? When you use the F word. When you factor out a common term, you use the smallest what?
Exponent.
And that's when you use the largest exponent and the smallest exponent. Most of you math teachers aren't going to show you that. They'll just let you find that out on your own. So if I give you x squared minus x, and I tell you to factor out a common term, what are you going to factor out? X to the first, because that's your smallest exponent. You always factor out your smallest exponent. When you find in a common denominator, you use the highest exponent. Okay? Does that answer your question? Okay, I don't like that now. You're still confused. Okay, let's do another one. Let's make one up so I can really confuse you. Let's go with 1 over 3x to the second plus 3 over 6x to the fourth minus 2 over 5x to the fifth. Okay, now take your time, each one of you, work on it and see what you come up with. If you have to, do your numbers separate. And of course, let me ask you this. What's the common denominator of x squared, x to the fourth, x to the fifth? X to the fifth. So you know that your answer is going to have x to the fifth in it because that's your common denominator in terms of the x's. Now you just got to find your common denominator with 3, 5, and 6. Oh, we just multiply 6 times 5, 90? No, you're wrong. Shut up. There's a lot of people that multiply them all together, and that's not the way you do it. 3, 5, and 6. 3, 5, and 6. 2, 3, 5, 7, 11, and sometimes 13. Why do I always pick those? 2 reasons. They're prime, and they're what? They're easy to remember. And they're easy to... If those 5 or 6 numbers don't go into these, chances are nothing's going to go into it. So, 3, give me a 1, that comes down, and a 2. 5, that comes down, 1, that comes down, and 2, 1, 1, 1. So what is it? 30. 30 is your common denominator. Put it with your highest exponent. So what is the common denominator? There you go. Now convert it. Now, for some of you that's a little bit rusty, use your arrows. A-R-R-O-W-S. Pronounce it however you want to. And to this day, if you walk into my office and ask me to do a problem that you're doing for some other teacher, I will use those arrows. I've used them ever since I was a student. And I got 3 degrees. So if I still use them, and I got 3 degrees and I teach this stuff, chances are you might need to be using them. But no, you don't. Some of you do, some of you don't. I don't know. How many times will 3 go into 10? So put you a 10 right here. And how many times will x squared go into x to the 5th? X to the what? 3rd. So 10x to the 3rd times 1 is 10x to the 3rd. How many times will 6 go into 30? And how many times will x to the 4th go into x to the 5th? X times x to the 1st, right? So what's 3 times 5x? 15x. Thank you, class. Appreciate the interaction. And how many times will 5 go into 30? And how many times will x to the 5th go into x to the 5th? X to the 0 times, which is what? 1. 6 times 2 is 12. 4. So what's our final answer? 10x cubed plus 15x minus 12 all over 30x to the what?
Yeah.
Comprende? Is that better? Make you feel a little bit better?
It's my whore.
It's what?
It's my whore.
Okay, good.
It's better. Aprende.
Okay, yeah. My whore, is that what you said? I'll have to use that. Como se dice my whore es Española? What does that mean?
I can say Spanish better.
What did you say? Is that what you said?
I said
My whore. What?
mejor.
Mejor. What does mejor mean?
Better.
Better.
And mejorar is to better.
Too better. Mejor. I got a friend, I call him Otto all the time. So that's about the only Spanish I know. He laughs every time I call him that. He goes, what are you telling him? I said, I don't know. They just told me to tell him that you are Otto. You know what Otto means?
Is it in Tonto? Like
No, it's the guy that instead of liking women, he likes men.
Oh.
So that's why I tell it's a joke between me and him, okay? Actually, he went through a divorce, and I went through a divorce, and there was a time that we were eating lunch and supper together a lot, and people thought,
I know what you mean.
we had to set that straight. Had to get us a couple of tamales to go with us. Tamales? What's a tamale? It's the thing you eat at a Mexican restaurant. All right. Let's do another. Let's do one where the common denominators do not look like common denominators. Then you can get discouraged. There we go. Blow it up? Yes, I will. You know, there's a rule that if you can't see the board, what should you do?
Sit in the front.
Move. Yeah. So I'm just telling you that. If I can't write on this board until I move it back down, so it'd be best if you either, you know, strain your eyes or move. Okay. Just pretty what?
Pretty small, I got Bible.
Okay. Well, then it's just me then. It's my fault. I'm sorry. And we all know who I'm going to blame it on. Who do you blame it on? There you go, Bush. Always blame Bush.
I think you could change the setting on your computer where you can make all the font fonts.
I know you can. I just don't do it because then I'd have to change it back because I am courteous, unlike some of these teachers that leave the computer to their settings and don't change it back for the next class, and I'm not going to do that.
You have your own username?
Yeah, I could. I do that, but I guess I ought to see about doing that. But then that's going all around the world for people that sit on the back row. And I'm not picking on y'all. It's just normally, where do people sit that can't see the board?
In the back.
On the back row. That's usually, and I'm not just picking on this class. There's I teach a lot of students. And every single time I get a person that can't see it, they'll go, "Will you blow it up?" You know where they're sitting? On the back row. Or they're sitting in the corner back over there. Dang old common sense. Dang old use your head. Okay, so if the denominators are not the same, you quit, right? Or you erase one of the denominators and change it to y plus 5 so they'll both match, right? That's what you do. No, that ain't what you do. Now, with 3 and 7, if I had a common denominator of 3, a denominator of 3 and a denominator of 7, what would I do to make that a common denominator?
Multiply.
You multiply them together. If they are prime, that is one of the rules, if you want to learn all those rules. In this case, they have nothing in common. So you basically put them what? Together. Now that does not mean make a trinomial. Making a trinomial is kind of like, I'm trying to think of an analogy. Think of something that's pretty bad, and then if you do one more thing to it, it makes the bad even worse. Okay? Think of something. I can't think of an analogy in real life where you're doing something bad, and
Try to do something good.
you try to make it better, but when you do something to it to make it better, it usually makes it what? Worse.
I got it.
Making a pot.
Is it okay for all ears?
Yeah, yeah.
Okay, good.
Okay, so, alright, so leaving the house late, like your boyfriend's leaving the house later than he should,
Uh-huh.
and then put you an alarm on your door that says, garage door, and then you put a magnet on it so it won't do it and the whole alarm goes off.
Yeah, that does make it worse. Yeah, that would make it worse. What about,
Like sculpting. Like if you add something to it, kind of makes it worse in a way.
you on drugs? That's comes from my cousin Vinny. I watched my cousin Vinny like 5,000 times. Anyway, no, that's not what I'm thinking of. How about this? How about you spill a quart of OIL on the floor? Okay? You spill a quart of OIL on the floor, and then you get a mop with dirty water to clean it up.
Yeah,
How about that? Does that make a good analogy?
I can feel.
Because what will that do? Nothing. It will do absolutely nothing. Because OIL cannot be picked up with a mop with water. You have to pretty much take a metal scrape and scrape up all of the OIL and put it in a pail. And then when you get all the OIL picked up with that metal scrape, then you need to take some dry towels and what? And clean it up. And then when you get that up, then you might can take some degreaser and degrease it, and then get that up, and then you might be able to mop it with Dawn and hot water. Okay? The whole point is, if you try to put water on a can of spilled OIL, what's it going to make? A bigger what? A bigger mess. So if I take these two binomials and I make them into a trinomial, I just poured water on top of OIL. Doesn't help. The only time a trinomial is worth anything is when it's factored. And you don't want to make a trinomial out of this until your very last answer, and that's just because you want to kind of condense as much as possible. So, we take this handy-dandy virtual marker and we make a common denominator of y plus 5 times what?
Y minus 6.
Y minus 6. Now, you've done this all your life. You just didn't know it. Let's go to another problem and I'll come right back to this. 1 over 3 plus 5 over 7. What's the common denominator? Most people say 21, but actually it's this. You actually put the two together and what? Multiply. Just people skip this step and they go to 21. Alright? How many times will 3 go into this? How many? 7 times 1 is 7. How many will this go into this? 3 times 5 is 15. In other words, you're used to saying 15. But what you actually do is you put the two you put the two prime numbers what? Side by side with multiplication, and you actually go 3, it'll go 7 times, 7 will go in 3 times, and that's what you actually do. But most of you don't do that, most of you do this. Put a 21 down here, and you do the division in your head. But actually it comes from the 3 times the 7 down here. Okay, so with that thinking, how many times will y plus 5 go into this? 7. No.
Once.
How many, Patrick? How many times will this go into this? This right here. Y plus 5. How many times?
Once, like 1 time.
Okay, let's go back to the second grade problem. And I'm not getting it.
I was finishing the other problem. 20 times.
No, don't try to answer it now. Be quiet. That will go into this
1 time.
3 times.
3 times.
And that'll leave, or 7 times, sorry. 7 times 1. So that crosses this out and leaves this, right? Right. Grab onto it. Hold it. Hold it. Hold it right quick. All right. Y plus 5 will go into this.
Y plus 5 minus 6.
Y minus 6 times. You get out of here, baby. Sit down. Y minus 6 times Y minus 6 is what? Y minus 6 what?
Squared.
Okay? Seven will go into this. How many times?
7. 3 times.
3 times. Are you on drugs? All right. Y minus 6 will go into this. How many times?
Y plus 5.
Y plus 5 times Y plus 7 is Y plus 5 times Y plus 7. Now, when you did this problem, the next step you got 20, what, I don't know, 5 to 22. What'd you put down here? 21. So you just, right here you had 2 21s. What made you put a 21, 21? What happened? It's you just carry the denominator, right? Now, I'm telling you this, not to insult your intelligence, I'm telling you this, you've been doing this all your life. Take these two numbers, you get a common denominator, and then they come down as what? 1. So what is this one going to come down as? Y plus 5 times what? Y minus 6. And what's your numerator going to be? A whole buttload of stuff to do it. Now this first one, you're not going to get, you can't get by with not doing a shortcut or the FOIL method. You're going to have to do it because there's nothing you can do to combine these two unless you do a shortcut for the FOIL method.
You want me to go ahead and say the numerator, if I got it?
No, because then you make a lot of people feel uncomfortable and they'll quit school, live in the ditch. So don't do that.
I would think the opposite would be true.
No, you would feel good about yourself unless you got it wrong.
Probably.
And then you would feel bad about yourself and then you would quit school and live in the ditch.
Oh, that's bad.
Yeah.
Oh,
The
that's
inverse.
So it's best just to keep your mouth shut. No, I'm just kidding.
Then you get mad at us for not saying anything.
I don't get mad at y'all. I only get mad at y'all when I'm in a bad mood.
Or you get
I
You only get mad.
I get temperamental when the class is odd. How about that? The personality of the class has a lot to do with me being in a good mood. This class is going to be okay, I think. I hope. But usually, you ever been in a class when the class personality is just terrible?
Yes.
It's awful. And you think it's awful for y'all? It's even more awkward for a teacher to be in a classroom like that. Because no matter what the teacher says, it's going to be awkward no matter what. Because of class personality. I think I'm crazy or not. Class personality has a lot to do with how fast or how slow the class seems to be going. All right, so what's this? Shortcut number what? Number 2, which is y squared minus what? 12y plus 36 plus brackets. Those don't need to be black brackets. They need to be red brackets. And why do they need to be red? Somebody tell me. Why are they important? Why are they important? Huh? Nope. Because that's not always going to be what?
Plus
What can it be sometimes?
a minus.
And what does that mean?
You subtract.
That means upside down. The world's going to turn upside down because you've got to distribute that minus what?
2 off.
Across whatever this is. So you need to get in the habit of whenever you do this type of problem, whatever you get here, you put in brackets and make sure you highlight those brackets. In this case, it doesn't matter because it's plus. But if that was a minus, it would change the whole outlook on this top row. So that's going to be y squared. Let's see, 5 plus 7 is,
Plus
I don't know, what?
12y.
12y plus
Plus
35? Okay, now in this case, you don't have to worry about it because the plus doesn't change anything. So I'm going to take that out. Take that out. And now you're ready to CLT. What's CLT? Whenever you distribute, because here we basically distributed. If you take the shortcuts and you take the FOIL method back far enough, basically what are you doing? You distribute, right? Whenever you distribute in an algebraic equation or expression, what is your next step?
Combine like terms.
Always combine like terms. So we go through and find y squared. What's y squared plus y squared?
Y quadrupled.
Thing over 2y squared. 1 can of OIL plus 1 can of OIL is equal to, what'd you say? A box of cereal? That's basically what you said.
Yeah.
Okay?
I remember cereal. But
Okay. 1 can of OIL plus 1 can of OIL is 2 cans of OIL, not a box of cereal. But y'all will come up with y to the 4th. That's the way it works. All right.
it's a Wednesday.
What is negative 12y plus 12y? Goes out.
No value.
And then 36 plus 35 is what? 71 over, and you'll see me write a little squiggle right there. That means basically whatever the denominator is. Now, are you able to reduce that? Well, is anything going to 2 and 71? No. 2 will go into 71, what? 35 and a half times or something like that? So you're not going to be able to reduce it anymore. Now what you do is you type that in, see if you feel good about yourself. What'd they get? They factored out, and that's fine. You can do that. But there's a 2y squared. They factored a negative out, and I don't care about that. Same answer.
So on our tests that we do,
Mm-hmm.
is the computer gonna be the one that's grading it, or are you gonna be
Yeah. And what if you get the wrong answer, but it's right? Then you SOL. Miss Evans, what happens if that happens in my class? What happens? Do you just get the wrong answer, or do you? That's it. See me during office hours or after class. No, not after class, because I usually got to go pick up my son after this class, which I got to go pick him up at 3:30. I usually will, and 9 times out of 10, usually your answer is going to be okay. If the answer is -72 and you come up with 5, then there's nothing I can do about that. But on something like this, I will give you that. But you, the student, has to take care of it. You have to come see me during office hours, okay? During office hours. And that's best on what days?
The days you're in the office.
Tuesday and Thursday are the best days. Why is Friday not the best day?
You won't be.
Because Friday is by appointment, okay? I'm just kidding. Just make sure if you come up here, make sure you tell me you're coming before you come up here. All right, this is a test question right here, so you might want to write it down. The first thing you should do on this problem is make everything a fraction. Make everything a fraction. That means if you got a whole number, you need to make it a fraction. And therefore, you can say, okay, I need to multiply through by the common denominator. Let me help you start off for those of you that have pulled a Patrick Starfish and sitting there. Whoa. 5/1 plus 8/y over 5/1 minus 8/y. What is the common denominator of 1y and 1y?
1 and y.
Yep, y. So I'm going to take my handy dandy red marker and I'm going to multiply by y/1 over y/1. Whatever your denominator is, whatever your common denominator is, you're going to multiply by itself over 1 over itself over 1. And what is y/1 over y/1?
Why?
1.
1.
Yeah, 1 last time I checked. Anything over itself is what?
It's 4.
So put a baby step in here. y/1, 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 y/1. I do this with all my algebra classes. Whenever I show this, I always put the baby step in here. That way, hopefully, people won't get lost. Now, what will happen when you do this? Okay, I wrote something down wrong. Let's start with the 1. That would make a difference. It would kind of help if I wrote the problem down right. We all know whose fault that is.
Obama.
No.
Bush.
No.
Bush.
You don't blame
Sorry.
Obama for anything.
Sorry, wrong president.
There you go.
Wrong president.
It used to be Clinton, but Clinton can't hold a candle to this one. Clinton got off with doing what he did. I did not have sexual relations with that woman, Miss Weston. I feel your pain. Anyway, this guy don't hold a candle to Bill Clinton. All right, so what happens here? 5y over 1 is 5y. What happens here? 8 over 5y minus 8. And you're done. And that's how you clean up a complex rational expression. Capiche? Okay, y'all. Let me see what else y'all got, and I'll tell you if y'all are ready for chapter 1 yet or not. Those are exponents. I showed you those. Yep. Oh yeah, that's inverse power rule. Flip these two. You get b to the negative 2 over a to the negative 3 raised to the what? Positive 4. Or you could distribute the negative 4 with the negative 3 and the negative 2 and get positive numbers. You could do it that way. Either way you do it, will you get the same answer? Yes. There's 2 or 3 different ways to do that one, but we've already covered this. This is inverse power rule. All right. Now let me get the roll, and then I'm going to let y'all go because I got to go pick up my son, and I got 2 or 3 of y'all that have to go somewhere, so I'm going to go ahead and let everybody go today. After I call the roll, you can skedaddle. Make sure you get the orientation done and the what? Review, because right now, y'all are scheduled to go into chapter 1 next week, okay? And I can give y'all a review test, but I figured I'd include the review on the Unit 1 test. All right, Anderson,
Here.
Barron, no Barron. Borth, no Borth. Crane, DeVore, no DeVore. Evans is here. Fisher, Hall, Keller is here. Lou is here. Moore, Nix, Pace was here. Page, Payella, Pruitt,
Yes, sir.
Saab is here. I hope I said it right. Is it Sab or Saab? Sab. Dadgummit. Sloger is here. Stone is not here. Walton and Woods. All right, y'all have a good day. Somebody turn that off for me. Hit the silver button on the right, where your thumb goes. Just hit it one time.
I don't really know where my thumb
Okay, hold it like this. Your thumb would be right at the back.
Oh, like.
See it right there? Did it stop?
Yes.
Thank you, sir.
The red light stopped.